called divergence and curl. How we calculate divergence and curl of a vector point function means a function f is given which is vector function, suppose f1i, f2j, f3k. So f given, then how we calculate its divergence? So divergence of f is also denoted by del dot f. What is del? We know very well. Del upon del x I cap, del upon del y j cap, del upon del z k cap. Take dot product with f. F means f1i, f2j, f3k. So it becomes del f1 by del x, del f2 by del y, del f3 by del z. So divergence, how we calculate? It's very easy. Whatever f given, see its I component, that is f1. f1 you differentiate partially with respect to x. Then differentiate f2 partially with respect to y, and f3 differentiate partially with respect to z, and add on. That is divergence. Partial differentiation, you know, partial differentiation means when you differentiating with respect to x, keep y and z constant. When you differentiating with respect to y, keep x and z constant. So it's very easy to calculate divergence. And now curl of f. Curl of f also denoted by del cross f. So what is del cross f? It's just determined value I cap, j cap, k cap, del upon del x, del upon del y, del upon del z, and then put f1, f2, f3 value here. So what is the value? It will be I cap, close this one, determinant of this means del f3 by del y minus del f2 by del z minus j cap del f3 by del x minus del f1 by del z plus k cap del f2 by del x minus del f1 by del y. So this is curl and this is divergence. So for curl, just put f1, f2, f3 value here and find out the determined value. It's so much easy. I will do with one question. Question: if f is equal to x square yi plus yz to yzj plus xyzk, find divergence of f and curl of f. So solution. What is divergence of f? Divergence of f means differentiate f1 with respect to x. So what is f1? X square y. If you differentiate with respect to y, what we get? 2xy. Differentiate f2 with respect to y. So what we get? 2z. Differentiate f3 with respect to z. What we get? xy. So what is the final value? 3xy plus 2z. This is divergence of f. Now I am going to calculate curl f. Curl f means I cap, j cap, k cap, del upon del x, del upon del y, del upon del z. What is f1? X square y 2yz xyz. So what is the value? I can differentiate this with respect to y. So what we get? Xz minus differentiate this with respect to z, means what we get? 2y plus j cap minus differentiate with respect to x, we get yz minus with respect to z, z is 0 plus k cap. With respect to x, it is 0. With respect to y, this is x square. So what is the final value? Xz minus 2y I cap minus yz j cap minus x square k cap. This is curl. So friends, in this way we can calculate divergence and curl. So first point, which is very important, divergence and curl we can calculate only for vector point function. Means function is given is vector form, then only we go for divergence and curl. And gradient we calculate only for scalar function. So please keep in mind, when it is given in notation form, means del dot phi, del phi and del cross phi. So always think about what is given. If del dot phi, it means phi must be vector that time, because it's cast called divergence, and in that case phi must be vector. If phi given in vector, calculate del dot phi. If phi given in scalar, calculate del phi. And for del cross phi, it's very simple, you easily come to know. So this is the way how we calculate divergence and curl for a given vector function. Now I am going to tell about what is their physical meaning and what are the properties which are important for divergence and curl. So now friends, I will tell the properties or application of divergence and curl. So first of all, what is the first property for divergence? If divergence of f is equal to 0, means a vector f given and you calculated their divergence and it becomes 0, it means f is solenoidal vector. It means it is solenoidal in nature, and solenoidal, you know, in that way it will move. So second, if curl of f is equal to 0, this implies f is irrotational. So a vector is said to be irrotational if their curl becomes 0. You calculate its curl, and if it becomes 0, it means vector is irrotational in nature. In this case, if f is irrotational, then there exists a scalar function phi such that f we can write minus of del phi. In some way we are telling f is conservative. So here phi is scalar function which is known as scalar potential. So sometimes they will ask the question like third. A vector given, prove that it is solenoidal as well as irrotational. Also find scalar potential for A. If curl is 0, then we can calculate scalar potential. So scalar potential, how we calculate? I will explain in that question. If that's so much, I will do third question. The third question means solenoidal and irrotational you will do by yourself. Now scalar potential, how we calculate? A is given. A is given what? 2x plus yz I cap plus 4y plus xz j cap minus 6z minus xy k cap. So first, so curl of A is what? 0. That you can do it by yourself. So it means A we can write is equal to minus of del phi. Sometimes some authors app itself taking a minus of del phi because that is the actual meaning. Otherwise you can take del phi also, it's nothing matter, answer will be same for in each case. So suppose A is equal to del phi. So what is A? 2x plus yz I cap plus 4y plus xz j cap minus 6z minus xy k cap is equal to del phi. What is del phi? Gradient. So del phi over del x I cap plus del phi over del y j cap plus del phi over del z k cap. So compare both sides. Because two vectors equal means I component is equal to I, j with j, k with k. So what is the value? 2x plus yz is equal to del phi over del x. 4y plus xz is equal to del phi over del y. Minus we take inside. So xy minus 6z is equal to del phi over del z. So we get this. Once you get this, how we calculate phi, I will tell you. From this first equation, integrate with respect to x. So what we get? This side phi is equal to x square plus xyz. Constant, no need to add. I will tell why. I will tell the other procedure. So what from second, what you get? Differentiate, integrate partially with respect to y. What do you get? 2y square plus xyz. Integrate partially with respect to z. So we get phi here xyz minus 3z square. Correct? Once you all get these three, write the non-repeated factors. Right? Non-repeated factors. So x square is there, nowhere. X square plus 2y square minus 3z square, and xyz is repeated 3 times. So write only 1 time. Don't write repeated factor. That is answer. This is the easiest way. So I hope you understand how we calculate potential function. For potential function, just write del gradient phi value and then equate with the given f. Then easily you can get del phi over del x, del phi over del y, del phi over del z. Integrate. Del phi over del x, integrate with respect to x, integrate partially with respect to y, del phi over del y, and del phi over del z you integrate partially with respect to z. And then add all terms, but take care, don't write repeated factors. If something is repeated, write only 1 time. Thank you. Hope you understand. So please do some questions based on your exercise, and it is very important part for any exam. Thank you.